Hello everyone, so this video should cover all the questions related to trigonometric identities. So just to revise the concept, I have question number 1, that is cos 45 by sin 45 plus cos 48, it should be tan 32 plus cos 45. Now, as I told you, you're just going to have to use the identity. Cos 45 is the same as sin 45. If you know the standard angles, you know that too. And cot 48 by tan 32. What did I tell you? 48 degrees and 32 degrees add up to 90. So this just cancels off and becomes 1. And cot 45, you know, is a standard angle, that's just 1. So 1 plus 1 plus 1 is equal to 3. Okay. Now let's do some proving sums, very easy ones. Let's get started with them. So first we have to prove tan A plus cot A is equal to secant A cosecant A. So this is your LHS and this is your RHS. So tan A plus cot A, so we can just rewrite that in terms of sin and cos. So we can write tan A as sin A upon cos A plus cos A upon sin A. And now we just have to find the LCM. So this is just sin A cos A upon, so this just becomes sin square A plus cos square A. So sin square theta plus cos square theta, as you know, is 1 upon sin A cos A, which is basically 1 by sin A into 1 by cos A. So this just cancels cosecant and secant. So yeah, so therefore LHS is equal to RHS. Pretty standard. Now let's get to the next one. Prove the following identities. So in this we are going to use the concept of rationalizing numbers. So first we have the root of 1 minus cos A by 1 plus cos A. So now what we're going to do is the root of 1 minus cos A upon root of 1 plus cos A into the root of 1 minus cos A by root of 1 minus cos A cos square A. So upon 1 plus cos A, isn't it? So what's the next step? Now as you can see, I'm going to apply an identity over here. That is cos square A plus sin square A is equal to 1. So 1 minus cos square A is basically sin square A. Right? This is what we already know. You can just rewrite the numerator as sin square A. And now, as you can clearly see, this and this cancels off. So it's just sin A upon 1 plus cos A. So this should ultimately be your answer. Is that your RHS? Yes, that's your RHS. So therefore, LHS is equal to RHS. Okay, now let's move on to the next one. 1 plus cos A upon 1 minus cos A is equal to tan square A upon secant A minus 1 whole square. Okay, now this side definitely looks easier, so I'll start with this side. We'll make this our LHS, tan square A upon secant A minus 1 square. So as we know, 1 plus tan square A is equal to secant square A. Therefore, we can rearrange tan square A as secant square A minus 1. Correct? We can rearrange that as secant square A minus 1. So therefore, it's just going to be secant square A minus 1 upon secant A minus 1, the whole square. So now we already know that this is kind of common, correct? We can actually see that this is in the format of difference of squares, right? This is the format of difference of squares. So this should be A plus B and A minus B. So based on that, we're just going to, do secant A plus 1, secant A minus 1 upon secant A minus 1, the whole square. This cancels off with this. So it's just secant A plus 1 upon secant A minus 1. 1 by cos A. 1 by cos A plus 1 upon 1 by cos A minus 1, right? So now what we're going to do is that cos A is going to go on top, right? And that cos square is going to come down. So it's ultimately just going to be 1 plus cos A upon 1 minus cos A. Yeah, that's what we got. That's our RHS. So therefore, LHS is equal to RHS. Okay, so now we have our LHS as 1 minus sin theta by 1 plus sin theta is equal to our RHS, secant theta plus tan theta, the whole square. Now, in this case, I'm going to rationalize it. So 1 minus sin theta upon 1 plus sin theta times 1 minus sin theta upon 1 minus sin theta. So this just becomes 1 minus sin theta, the whole square, minus, that's a square, a plus b, a minus b. So a square minus b square, which is just 1 minus sin square theta. So now we know our identity. 1 plus cos square theta is equal to sin square theta. So 1 minus sin square theta would just be equal to cos theta. So we can make our denominator cos theta. So 1 minus sin theta upon cos square theta, the whole square. Now what we can do is, since both of them are in squares, we can just put, a whole bracket. So this is 1 minus sin theta upon cos theta, a whole square, right? Whole square. So we need to do is, first we need to just open up this bracket. So this just becomes 1 by cos theta minus sin theta by cos theta. Now 1 by cos theta, as we know, it's nothing but secant theta minus sin theta by cos theta is tan theta, the whole square. Is this your RHS? Yes, this is your RHS. So therefore, LHS is equal to RHS. Pretty straightforward. Now let's move on to the next one. Prove that sin A minus 2 sin cube A by 2 cos cube A minus cos A is equal to tan A. So in this case, as I can see, we have a sin A here and a sin A here, and we have a cos A here and a cos A here. So the first thing I would do in this case is I would factorize sin A out and cos A out. So in our LHS, we have sin A, which is factored out, so sin A, 1 minus 2 sine square A. Because I've just factored sine A out. I. Now I'm going to factorize cos A out, cos A into 2 cos square A minus 1. I'm not really changing anything here. So now I don't know if you see it, but I see that there's an identity here. We have sine square A. Sine square A can be rewritten as 1 minus cos square A. But we already have a 1 here, right? So it can't be, so 1 minus sine square A cannot be cos square A. But sine square A can be 1 minus cos square A. So in this case, we'll say sine A times 1 minus 2, 1 minus cos square A upon cos A. This just remains the same. So now if you look very closely here, you see that this is basically just the same thing, right? This is just 2 cos A minus, that becomes 2, and then there's a plus 1 here. So this also just becomes sine A by 2 cos square A minus 1 upon cos A, 2 cos square A minus 1. Now since they both are multiplied together, we can just cancel this off and we can cancel this off. So it's nothing but sine A upon cos A, which is nothing but tan A. So ultimately all this just results to tan A. So therefore LHS is equal to RHS. Let's move on to the next one. This again is quite an easy one. It just involves a little bit of factorization. If you can see here, we have a secant here, we have a secant here, we have a tan here, we have a tan here. So easily we can just factorize this out. So what I'm going to do here is, first I'm going to write my LHS, which is nothing but sec to the power of 4 theta minus sine square theta. So what I'll do is, I'll factorize out secant square theta, sec square theta minus 1. Right? So now that I've factored out sec square theta minus 1, so now what's our identity? Tan square theta is equal to sec square theta. So now if I take this sec square theta, and if I take 1 to the other side, it's just tan square theta, right? So this is nothing but sec square theta times tan square theta, right? So sec square theta can just be rewritten as 1 plus tan square theta, 1 plus tan square theta times tan square theta, right? So now you just multiply. I just think you need to multiply it. So it's just 1 into tan square theta, just tan square theta, plus tan square theta into tan square theta is tan to the power of 4 theta, which is your RHS. Yes, it's your RHS. So therefore, LHS is equal to RHS. So now I'm just going to tell you the basic concepts for heights and distances. Okay, I'm not going to actually cover the whole chapter. I'll make a video on that. So for heights and distances, basically, till now, what have you been doing? You've been doing trigonometric identities, right? You've been doing sine square something plus cos square something is equal to 1, right? You've been doing identities, proving sums. Ultimately, you have to realize that all the things you're writing, sines, causes, they are all ratios. So we have to ultimately solve something to remember these are ratios. Like for example, we have a right angle triangle over here, right? We have some value x, y, and z. If you want to say what the base of this is z is a base and y is a hypotenuse, so its cos would be z by y, right? Z by y would be the cos. Similarly, its sine would be perpendicular by hypotenuse, which means x by y. So these are all ultimately ratios. That is what we need to understand, right? So you're basically solving these sums, but in a more applicative way. Like they'll give you word problems, and based on that you have to solve it. So there are a couple of rules. First of all, whenever you get a question regarding this chapter, height and distances, you'll get at least one question on it in boards, right, for a 4 or 5 marker. And usually you have to draw the figure. Now they won't give you the figure, you have to draw the figure, and there's something known as the angle of elevation and the angle of depression. Your angle of elevation and depression basically mean the same thing. Like the only difference is if this is your right angle triangle, and this would be your angle theta, right? If it is the angle of elevation is a point that's below, right? That is the angle of elevation. But if you look on top, like from your eye level, if you want to look below, that would be the angle of depression. Whenever you get the angle of depression in a question, you always have to draw a line over here. But ultimately, this angle would be over here. Since they are exterior alternate angles, this angle would always be equal to this angle. So you don't really have to, write it twice. You just have to draw that line whenever they say angle of depression, right? So that's your basic concept of heights and distances, right? So related to that, we have many word problems that we'll solve soon. So I'm just going to do a basic one. A vertical pole is 12 meters high and the length of its shadow is 12 root 3 meters. What is the angle of elevation of the sun? So these kind of questions, what you have to do is you have to analyze it, right? You have to analyze it and you have to draw basically a diagram. So let's say that this is your right angle triangle. All these questions, remember, there's always a right angle triangle. So what are they saying? The vertical pole is 12 meters high. So this is the vertical pole. We'll say 12 meters, right? So this is 12 meters. So first of all, we'll mark the sides. We'll say A, B, and C, right? A, B, C, these are the sides. Now the vertical pole is 12 meters high. Its shadow is 12 root 3. So that means the base is 12 root 3. So we can do Pythagoras theorem, ultimately find the hypotenuse, but that's not what they're asking. They're asking what is the angle of elevation of the sun. So when they say angle of elevation of the sun, don't get confused. Okay, it's just the sun is at this point, so this would be the angle of elevation. We have to locate this basic angle, that is theta, right? Ultimately, what are we locating? Now this would be tan, right? Because see, we've gotten the perpendicular, we've gotten the base. What is the ratio between the perpendicular and the base? It is cot or it is tan, right? But in order to find the angle of elevation of the sun, we have to do tan. We have to take the ratio of tan. So what are we going to do? We are going to take 12 upon 12 root 3. Right, this is what we'll take. So this cancels off with this to form 1 root 3. 1 root 3 is what is formed, right? Since they're asking angle of elevation of the sun, basically you have to see that it is always tan. Why? Because the sun is on top. So it's the perpendicular divided by the base, right? Now this is in the form of one of your standard angles. So tan theta is equal to 1 root 3. Now tan theta ka value is, see, all the tan values you need to remember. Tan 45 though can't be tan 45 because tan 45 is 1. It cannot be 90 or 0 for sure. It cannot be 45. It has to be either 30 or 60, right? So, based on standard angles, it will be 30. So, therefore, theta is equal to 30 degrees. So, like this, they can ask you either locate the angle of elevation. One more type of question they can give you is they can say that, okay, from the top of a cliff, they'll give you the height of the cliff. This is the height of the cliff. They'll give you the perpendicular. Basically, you have to analyze it, draw the diagram. They'll say this is A, B, and this is C, right? So we'll give you the height of the cliff. We'll say 50 meters high. That means at the top of a cliff that is 50 meters high. That means the perpendicular will be 50 meters high, right? And the angle of depression would be 30 degrees. We'll say that angle of depression is always 30 degrees. Whenever we give you the angle of depression, remember to draw that line that is there, distance, right? We have to ultimately calculate. What are we calculating? We are just calculating the base, right? We're calculating the base. That means you know that if this is 30 degrees, that means this would also be 30 degrees because they are exterior alternate, right? So 50. So what is the relation between this thing AB and 50? What is the relation between it? Tan, right? So we can again do tan. Most of these questions are tan. So tan, if we say tan, what is the angle? Tan 30. What's the value of tan 30? Tan 30 is 1 root 3, right? So 1 root 3. And what is the ratio? Tan is always a perpendicular by base, right? So we have 50 upon the base which we've been given is AB. Right, we've been given this ratio AB. Now we ultimately just have to solve for AB. So if we take AB to that side, AB is equal to, we take 50 root 3. We can solve it ultimately. Now you need to remember the values of root 3. That's 50 into 1.732. And if you solve it, you'll get it as 86.6, right? You'll get it as 86.6 meters. Usually now what you're supposed to do is you're supposed to round it off and say approximately 57 meters. If it was 56.2 meters, you have to say it is approximately 86 meters. Okay, that's how you round off numbers. So this is how you basically solve questions related to heights and distances. It's quite simple. You just have to understand the word problem, construct the diagram in your head, construct it in your paper also. Don't forget to construct it in your paper. Right? After you construct it in your paper, then you just do your regular solving. You'll always be given the values. Right? If you're not given, you're supposed to locate it. Sometimes you can say, okay, this is a right angle triangle over here. Right, and then this is something, and then they'll give you one angle here. This angle is always greater than this angle because this is sloped more, right? So let's say this is 60 degrees, this is 30 degrees, right? And then they'll give you maybe the perpendicular, right? And then they'll give you this value, and then they'll say this is twice of this, is something like that, right? They can form any word problem. You have to analyze it in your head, and then you're supposed to basically construct it, right? You construct the diagram. After you constructed the diagram, very easily you can do it. Either you apply Pythagoras theorem or any of the trigonometric identities, and wherever you see roots, you're all in the denominators always rationalize them. And one more thing is sometimes you may get non-standard angles. For that, you have to use something called a log table, which we'll do in the next video. I'll also teach you how to locate various ratios on the log table, and based on that also we have to solve sums, and there's rules for that also. You cannot divide by 4 decimal places. That means you have to use a complementary concept, right? But then I also have to teach you about significant figures. So for now, that's it. You need to remember about heights and distances, just applicative way of solving trigonometry, and I'll definitely cover the entire concept very soon. So thank you for watching.